In this video, we'll be discussing natural logarithms and how to evaluate their expressions and solve equations using them. So instead, in the past, we discussed that we had a base 10 for logarithms. And now we're going to talk about the fact that there is something called a base e. E is actually an irrational number, approximately equal to 2.71, blah, blah, blah. Exponential functions with a base e are actually useful a lot for describing continuous, hence continuous, not exponential growth or decay, but continuous growth or decay. And if y equals x, then the inverse would be written as natural log of x equals y. So e to the x and natural log of x are inverses of each other. So just like log of x and base 10 are inverses, natural log and base e are inverses. So for example, if the natural log of x equals 2, then e to the 2 is the same thing as x. Again, if you think of natural log as understood in e raised to the 2, equals x, which it does. Same thing, if e to the x equals 10, then the natural log of 10 equals x. So the properties and rules apply just like they did with logs, that if you had multiplying, then you can be adding two natural logs together. If it's division, you'd be subtracting. And if you had an exponent, you can put it out in front. Same thing, the natural log of 1 is 0, because if you think about that being e to the 0, because e is a number, it's 2.71, so forth. So any number raised to the 0 is going to give me 1. Same thing, natural log and e are actually inverses of each other, which means they will cancel each other out, leaving you 1. And again, natural log and e cancel each other out, which is why your exponent becomes your answer. And the same thing in this case as well. So for example, if I had the natural log of x minus 1 equals 4, and I really need to solve for x, then I need to take the inverse. In a previous video, we discussed that if this was the log of a number, then you would make it an exponential of whatever that base is. Like if it was just log base 10, then it would be 10 to the 4th. Same thing here. This natural log has an understood of e. So you would rewrite this as e to the 4th equals x minus 1. So the first thing you need to do is figure out what is e to the 4th. So e is actually you would hit this second button and then the natural log, and that gives you your e. So e to the 4th is 54.6. And that equals x minus 1. So to solve for x, you would just add 1 to both sides. So your answer is going to be 55.6. In this case, we need to solve for x, but first we need to get everything else on the other side. So I'm going to add 1 to both sides. And I'm going to divide by 7. Now, we need to get rid of x, and we need to get x out of the exponent. And so what we're going to do is take the natural log of both sides, basically is what we do, because the natural log of e cancels, leaving you x, and then the other side, you actually get the natural log of 3, which, again, you pull up your calculator, and you just click the natural log button of 3, and your answer is basically 1.1 if you were to round it. So x would equal roughly, approximately 1.1. In this case, you have natural log. So what you're first going to do is get rid of the 2 by putting it down front. So 2 natural log of x minus 3 equals 4. Now, to solve for natural log, we are first going to get rid of the 2. So natural log of x minus 3 equals 2. Now I got to rewrite it in the e form. This natural log has a base that is understood to be e. So e raised to the second power equals x minus 3. So first we got to figure out what is e squared. So we need to hit second natural log to get to the e. So e squared is 7.39. And that equals x minus 3. So to solve for x, I'm going to add 3. So 10.39 is going to be my answer. In this form, again, e is by itself, so we can go ahead and automatically take the natural log of both sides. Natural log and e cancel, leaving me 2x minus 1 equals the natural log of 5, which natural log of is 1.61. So first I'm going to add 1 to both sides. So I'll get 2.61, and I divide by 2, so I should get 1.305, I believe, is your answer when you divide by 2. Now, I do want to make a comment that you do not technically have to multiply both sides by natural log. That is what is actually happening. When you rewrite this, you're basically saying the natural log of 5 is going to be equal to the exponent because the natural log and e cancel each other out. You're basically rewriting it as an inverse. Now, real life connection is when you have anything that is compounded continuously, then you would be able to figure out certain types of interest rates. So for example, the initial amount is P, A is the final amount, R is the rate in decimal. Do not give it to me that is in the percent. You actually have to write it as a decimal. So for example, you invest $1,000, okay? That is your initial amount that you're investing. Compounded continuously, obviously, because we're using the formula. Here's the interest rate. Now, but you got to rewrite it as a decimal. You can't put 1.5 in R. It has to be 0.015. And then this is automatically going to be your time. So your initial is P, E raised to the rate times time. So E is going to be 0.015 times your time. So in the calculator, you're going to write, you're going to type in 1,000 and then hit second natural log of 0.015 times 5. Now, some calculate, which is $1,077. Now, some calculators don't actually put the numbers in the top. So what you will need to do is, according to Please Excuse My Dear Aunt Sally, is you need to do a parentheses, 0.015 times 5. Close the parentheses in order to be able to get your answer. If you don't use parentheses, if you have a TI-83 or a TI-84 that's not a plus, you're going to have to use parentheses, so be really careful about that. So $1,077.88. So it would be $1,077.88 would be the amount of money you would have 5 years later. Same thing is going to apply, except we now want to know how many years it would take to double your money. So we know that it's going to be A times P, A equals P E to the RT. We know that the initial amount is $1,000. We know that the rate is 0.015T, but we don't know how many years it's going to take. And they want to know to double your money, meaning if you invest $1,000, they want to know how many years will it take for you to earn $2,000, because that's literally doubling your money. So now we have an equation that has a variable and this exponent. So the first thing we need to do is we need to divide by 1,000. So we will get 2 equals e to the 0.015t. Now, how do we get rid of an e? By taking the natural log of the other side. So the natural log of 2, according to the calculator, is going to be 0.693 equals 0.015t. So to solve for t, we're going to divide by 0.015. So if you pull the calculator back up, hit divide from that answer of 0.015, and the answer is 46.2 years. So it will take a little over 46 years for you to double your money in at that interest rate compounded continuously. So let's recap. We're going to solve these two equations. So I want you to pause the video, attempt these problems, and then resume when you're ready to see the answers. So to solve for e, I first need to subtract 4. So we'll get e to the x divided by 5 equals 3. Now, how do you get rid of e? That means you take the natural log of the other side. So natural log of 3 is going to give me my exponent. So now, to solve for x, I'm going to multiply both sides by 5. So my answer is going to be 5 times the natural log of 3, which is 5 times the natural log of 3 is 5.49. In this case, before I mess with the natural log, I first need to get rid of the 3. So natural log of 2x minus 5 is going to equal 6. Now you got to think of this as an understood e. So to get rid of the natural log, it means you're raising the other side of to the power with a base e. So e to the 6, e raised to the 6 is going to equal 2x minus 5. So to solve for x, I'm going to add 5 to both sides. So it'll be e to the 6 plus 5. And then to solve for x, I'm going to divide by 2. So e to the 6 plus 5 divided by 2. So I'm going to type all that into at once. So parentheses, second natural log of e to the 6 plus 5, and then divide that entire numerator by 2, and I'll get 204.2 as my answer.